Hey everybody, my name is David and this is my seventh Connect. It's been quite a thrill to see the ecosystem grow from Oculus Share to the creative industry that it is today. As the manager of the VR development environment team here at Facebook Reality Labs, we work every day with devs like you. Actually, my main goal is to maximize your return on investment in order to grow the overall VR ecosystem. Our team builds the tools and APIs you use to make VR apps. And one of the biggest pieces of feedback we receive every time we ask is that our edit compile test loops are too slow. Over the last few months, our Unity and UE4 integrations have both shipped significant iteration time improvements. We've also made some changes that benefit native devs. For Unity developers, we've shipped OVR Build APK and Run, OVR Quick Scene Preview, and shader stripping. Together, these improvements have made iteration 2 to 5 times faster for our Horizon and Strike teams. Check out Neil and JJ's talk for more. For UE4 and native developers, we enabled skip APK build when iterating on code, so developers can bypass repackaging an APK when iterating on code changes. Additionally, we've added support for fast build, which can help greatly speed up large code compiles by leveraging remote compute resources. Learn about these iteration time improvements and other engine partner improvements at our platform focus sessions for Unity and Unreal. Altogether, we've sped up UE4 iteration by several fold. Check out Joe and Steve's talk for more details. We've also dedicated time to improving our code samples and documentation to provide you with better support throughout development. We recently shipped a collection of UE4 code samples called the Essentials that covers key VR use cases, including locomotion, shadows, text, and more. We've revamped our documentation portal to be device-focused so you can access relevant information quicker. Additionally, we've added more guides such as mobile optimization tools, mixed reality capture and casting guide, app submission guide, and more. Finally, we restructured the navigation framework of the Oculus developer dashboard, made enhancements to the app submission process, and redesigned the entire site with a heavily supported, modernized design system enabling you to efficiently discover and navigate through different tools, more easily optimize your app submission, and manage your applications. These changes establish a foundation for upcoming major improvements to the site. We'll continue to invest in this area, so keep an eye out for more code samples, even better documentation, and an improved developer dashboard. In addition to improving our development experience, Facebook and Oculus have played a central role in the development of OpenXR. OpenXR aims to simplify VR development by enabling developers to reach more platforms while you're reusing the same code. We announced in July that we're going to officially support OpenXR 1.0. Developers can now submit their OpenXR apps to the Oculus Store. We've also recently launched APIs to give you precise control over the color of each pixel, allowing you to immerse users in vivid, nuanced colors that match what you mastered. We know that one of the most time-consuming aspects of developing for Quest is performance tuning of your app. This year, we shipped 3 tools that will help take the guesswork out of profiling, allowing you to optimize more quickly and effectively. We've also been working with Qualcomm over the past year to bring you the Performance Interface Library. The PIL is a low-level API that gives us GPU information that you could only get through Snapdragon Profiler before. It's embedded in the Quest operating system and gives us 2 main types of information: render stage metrics and real-time metrics. This information is now available through 2 more tools: GPU systrace and OVR GPU Profiler. Now you can know exactly what the GPU is working on with minimal overhead. First, OVR GPU Profiler is a command-line tool that provides real-time GPU pipeline metrics and render stage tracing. Second, GPU systrace aggregates GPU data such as render stage timings with call stack traces to shed light on how different parts of your code contribute to GPU perf. Third, RenderDoc for Oculus. Now, RenderDoc is one of the most popular graphics debugging tools, and it's already heavily used on Quest. But we've released an Oculus-specific edition, which has been modified to provide access to low-level GPU profiling data from Quest and Quest 2. Before jumping in with these tools, our real-time perf overlay OVR metrics monitor is still the best starting point for identifying perf hotspots in your app. If you're interested in perf optimization, I highly recommend the upcoming deep dive session with Remy Polandri on profiling. Finally, I'm thrilled to announce the work of our developer success team. Today, we're launching the Oculus Developer Hub, a cross-platform desktop tool to reduce development friction and improve two-way communication with our developers. ODH streamlines common Oculus development tasks and helps everyone at your studio, developers, artists, QA, marketing, to be more productive in their roles. ODH will enable easier device management, debugging, casting, screenshotting, and video recording. It'll enable host and device-side package management, notifications, and platform updates. Over time, it'll do even more. Download ODH today and check out our ODH Lightning Talk later this afternoon with the development team. Before I hand off to Shira Gordon, who will talk about Oculus Media Studio and Oculus TV, I wanted to thank you for all the input you've provided that's resulted in these improvements. Your contribution drives our roadmaps. Please keep the feedback coming. Take it away, Shira.